Imagine burning through literally millions of dollars and having absolutely nothing to show for it. Ouch, right? Welcome to this explainer. Today, we're going to demystify that absolutely crucial planning phase, the make or break moment that determines if an IT project thrives or just becomes a massively costly disaster. So if you've ever wondered why some tech initiatives completely change the game while others just fail spectacularly, well, you're exactly in the right place. All right, let's just dive right into our roadmap for today. We'll be looking at the roots of IT failure, mastering the SDLC, creating the system request, solving problems with the pieces framework, running the feasibility test, and finally, navigating the final selection. Section 1. The roots of IT failure and why projects go wrong. We really have to start by looking at the dark side of systems development first, just to truly grasp why this planning phase matters so much. It's honestly a staggering statistic, but somewhere between 30 and 70% of IT projects fail. That is a massive margin of error, and we really need to understand what's going wrong here. And when we say failure, we're talking about projects that are flat out abandoned, come in wildly over budget, or just don't deliver the value they originally promised. Look, if you're going to lead an IT project, you absolutely need to know how to stay out of that 70%. Take the airline Qantas as a prime example of this. Look at that unbelievable $200 million price tag on their Project EQ. That is a massive loss fueled by poor planning and an attitude that pretty much just disregarded users. After 4 long years of effort, they literally just canceled the whole thing. Sure, a super complicated technical infrastructure completely bogged down by 700 legacy applications didn't exactly help, but the core issue, it was management failing to understand basic user needs and frankly, just not planning properly for the transition. Because as we see here, often the cause of failure isn't technical at all. It's exactly what you dread in a corporate environment. A total lack of management support, super ambiguous goals, and a team of overworked people who kind of just want the project to die. I mean, you can have the best technology in the absolute world, but if the organizational environment is toxic or misaligned, your project is basically doomed right from the start. Moving on to Section 2, mastering the SDLC, bringing order to the chaos. Because to avoid these total disasters, organizations have to rely on a specific, structured methodology to, well, bring some order to that chaos. The Systems Development Lifecycle, or SDLC for short, is basically our 4-step survival guide. It flows logically, right? From planning to analysis to design and finally implementation. Think of it like building a house. You wouldn't just go and pour a concrete foundation without a blueprint, would you? So today, we're focusing entirely on that foundational first step, planning. This is where we figure out exactly why we should even bother building the system in the first place. And driving this whole methodology is the systems analyst. But here's the thing, it's actually not just one person trying to juggle the whole shebang. The systems analyst role really breaks down into various specialties, kind of acting as change agents. You've got business analysts zooming in on the business value, requirements analysts pulling together stakeholder needs, infrastructure analysts tackling the hardware and networks, change management analysts working through user resistance, and of course, project managers keeping everything tightly on budget. It really takes a specialized team to make a system successful. All right, Section 3, the system request, initiating the project. Every major project starts out as just a spark of an idea, but it needs a formal document to actually ignite real development. The system request is literally the document that determines if your idea lives or dies. It captures everything, from high-level business functionality down to strict government constraints. Our project sponsor officially kicks things off by clearly defining the business need. Things like improving customer service or bumping up sales. And from there, they lay out the expected functionality, the actual business value, and any special issues, like, say, a totally non-negotiable holiday release deadline. To put that into perspective, let's say a local dealership in a chain like CarMax wants to build a new web-based sales system. Their system request isn't just going to say, hey, we need a cool website. No way. It outlines crystal clear, tangible business value to justify the cost. They might project exactly $750,000 in new sales, plus a $50,000 reduction in customer service calls. The point is, the value has to be totally quantifiable. Which brings us to Section 4, solving with pieces, our diagnostic framework. Because before you can even write that request, you have to accurately pinpoint the underlying business problems and opportunities. Analysts use this pieces framework as sort of a diagnostic tool to uncover issues, things like lagging response times, total information overload, or just super inefficient processes. It stands for performance, information, economics, control, efficiency, and service. By basically running through this checklist, analysts can figure out exactly why a new system is even needed. Are users dealing with way too much bureaucratic red tape? Are data inputs completely redundant? Pieces is great because it brings all those hidden problems right into the light. Section 5, the feasibility test. Will it survive? Once that system request is actually submitted, it enters the crucible of the feasibility analysis to see if it can actually survive out there in the real world. The project's merits are assessed against three major hurdles: our technical familiarity, the financial return, and whether the organization is actually going to embrace the change. So technical feasibility asks, can we build it? Economic feasibility asks, okay, but should we build it? And organizational feasibility asks, if we build it, will they actually come and use it? And here's the catch. You have to pass all three of these to proceed. To really answer that should we build it question, analysts rely on strict financial models to assign hard, concrete numbers to both our tangible benefits and our development costs. We're looking at metrics like net present value, which shows us the value today of our future returns. Then there's return on investment to measure the revenue generated relative to the cost. And of course, the break-even point to see exactly when this project is finally going to pay for itself. Notice here how we lay out all the operational and development costs side by side against our benefits over time. That's how we calculate the final net present value. You can clearly see the hardware, software, and labor costs mapped out year by year, and we measure those against the increased sales and reduced inventory costs. Factoring in the time value of money, because a dollar today is worth more than a dollar tomorrow, we simply subtract the present value of total costs from the present value of total benefits. So it all comes down to this crucial point, this magic number right here, 0. If your calculated MPV is 0 or greater, congrats, the project is financially acceptable. It means it's actually going to add value to the organization. But if that final number drops even a bit below 0, the project is completely unacceptable from a financial standpoint. It's essentially dead on arrival. All right, Section 6, the final selection and the approval committee. Listen, passing that feasibility test is a massive victory, for sure, but there's still one final boss you have to face before any development actually begins. An approval committee is going to sit down and review that feasibility study. And remember, even highly profitable projects might get rejected simply because they don't balance out with the organization's broader portfolio at that exact moment. The committee has to make some really tough strategic trade-offs. Maybe there's a limited budget, maybe a corporate merger is on the horizon, or maybe another project is already out there meeting these exact same business needs. Basically, passing feasibility doesn't always guarantee a green light. As we wrap up this explainer, I really want to leave you with this final thought, especially regarding organizational feasibility. You can build a technically flawless, highly profitable system, but if the stakeholders ultimately reject it, was it really a success? At the end of the day, project survival depends just as much on human psychology and organizational support as it does on code and cash flow. So definitely keep that in mind as you embark on your own IT planning phases.